Hello, this video is to help you with section 5.3, which are properties of logs. So on the first few, well, at least on number one, we're going to use the change of base formula. So if you have the log of 16 base 3, some of your calculators may allow you to type that in just as it looks. But if not, you'll use the change of base formula, which just says to take the log of 16, divide it by the log of 3. So the base always goes on the bottom. And that when you type that into your calculator, you should get approximately 2.524. All right, and so that's really kind of a calculator problem there. For number 2, it says find the exact value and don't use a calculator. So if I have the natural log of e to the 6th plus the natural log of e to the 9th, well, if you have the natural log of e raised to a power, then the result is just that power because the natural log of e itself is just 1. And so we end up with, you can move the 6 to the front, and so it'd be 6 plus 9 because this goes away, and so we end up with 15. So you just need to add those exponents together. All right, number 3 says approximate the logs using properties of logs given that the log of 2 base b is approximately 0.3562 and the log of 3 is approximately 0.5646 and the log of 5 is approximately 0.8271. So if we're trying to find the log of 3 over 5, since it's division here, I will use subtraction. So the difference of logs. So I would have the log of 3 base b minus the log of 5 base b. And then I'm going to replace this with what is given, and I'm going to replace this as well with what is given. And so I end up having to do the log of 3, which is 0.5646 minus the log of 5, which is 0.8271, which gives me approximately negative 0.2625. All right. So we have another one that's very similar. This time, though, it's telling us to find the log of 45. And so what I'd like to do is I can rewrite 45 using either 3, 2, or 5 and 5. All right, so I can replace 45 with what would make that equal 45. So I know that 3 times 3 times 5 is 45, right? Because that's 9 times 5. And I'm given these things, the 3 and the 3 and the 5. So I'm going to do the log of, so I'm going to use 3 times 3 times 5. And since it's a multiplication, the property says to add. So it's going to be the log of 3 plus the log of 3 plus the log of 5. And then once again, I'm going to use what is the log of 3, which is right here. So 0.5646 plus 0.5646, and then plus 0.8271. So add all that together, I get about 1.9563. All right. This next one says use the properties of log to expand the expression as a sum difference and or a constant multiple of a logarithm. So I have the natural log of 5x, but really it's 5 times x. Since it is multiplication, I will use addition. So I can write this as the natural log of 5 plus the natural log of x. All right, let's move on to number 6. So same thing, and what we're going to do is anytime you have an exponent here, you can actually move it to the front. So this is just the 5 times the log of x base 6. So we're just moving that exponent to the front. All right, so for this next one, I have the natural log of x y to the 6th power, which is x to the 6th, y to the 6th. So I can rewrite this as, since this is multiplication, I'll use addition, and these exponents will go to the front of the log. So it's going to be the 6 times the natural log of x plus 6 times the natural log of y. All right, number 8. Same idea. This time we have a lot going on here. So I have w to the 3rd power divided by v. And this division does mean subtraction. All right, so I'm going to take the exponent to the front. So the 3 is going to go in front of the log, w, base 8. And then because of this division, that property is subtraction. And then I'm going to have the log of v base 8. All right, which of course is right here. All right, number 9, I have the natural log, of x times y times z to the 5th power. Okay, so since this is multiplication, I'm going to use addition. That is the property. And so I'm going to have the natural log of x plus the natural log of y plus, and then the 5 goes in front of the natural log that goes with z. Okay, let's keep going. Number 10, similar thing here. So I'm going to have the log of 15 and then times b to the 6. So plus 6, because the 6 goes in the front, log of b. All of these are base 4. And then plus, again, because this is all multiplication, the log of c, base 4. So we're just rewriting these. We're not really having to do very much else. This one is very similar. I'm going to have a 5 in front of the log for x. And then this division symbol means to minus. And anything in the denominator you're going to see is going to have a subtraction symbol. And then the 5 is going to go on the front of log y, base 9. And then minus again, because this piece is in the denominator. So it's going to look like that. All right, and then on number 12, we do have this expression, which I'm going to rewrite this. So anytime you have something raised or as the 5th root, we can actually write that to the 1/5 power. So you can pretend there's a 1/5 there, and that's how we end up with 1/5 for each of our answers. And so I bring the 1/5 to the front, but really it's like dividing by 5, so it's a natural log. And you can imagine a 1/5 here, but they're not going to draw a 1 there, right? Y, and then plus, and the reason why it's plus is because it's in the numerator, the natural log of z over 5, and then minus, because of the division, 6 times the natural log of x over 5, because that has an exponent. All right. Let's try number 13. I think it's the last one. So now we're going to write this as a single log. So I'm going to write the word log. So it wants a single log. And then this time I have 8x, which I know is going to be in the top. This minus means division. So I draw my fraction. And then this 2 is going to go back on the exponent of the x. And so it's going to look like this. And you can see they actually don't want you to simplify. I can tell by my answer. All right, I hope this helps, and I hope you have a great day. Bye.